All right, so today it's day 27. Happy Christmas to everybody. I'm a bit late on this video, but I hope everyone understands. I'm gonna show exactly what I studied today. So basically, I was reading through the book we have been working on. I came back to the RAG part in which they explain about the advanced stuff, and I took some notes. I'm gonna go over them quickly. These days I'm not studying as much. It's understandable, I guess. And once vacations is finished, I will continue as always. But from what I read, basically we have the vanilla RAG optimization, but we have the vanilla RAG implementation in which we basically have some sort of data. We chunk them in a fixed size. We compute some vector embeddings and build like a database. Then for a given new query, we search with a metric with like cosine similarity, the relevant chunks, and we inject these together with the original query into an LLM to get an answer, right? So we can have some sort of optimization in this workflow, and there are three main stages in which we can optimize it, right? The first one is in before doing the retrieval. The second, it's within the retrieval itself, and finally for post-retrieval. Regarding pre-retrieval, we have many different techniques that we can use. We have mostly two of them that they cover. One is data indexing, and second, it's query optimization. Regarding data indexing, we have many different examples. For example, we have the sliding window technique. Maybe I should make a diagram. So we have no, not this one. What was it? Sliding window, right? Yeah, we have to make some overlap text between the chunks. So if I have I don't know, the word hello world, and we make embeddings into embeddings. What we do is embed this into hello W, let's say, and W world, like O world, and there exists like some overlapping between these two. So this is the example, but this then goes into a mapping into numerical representation. All right, so this is the first technique in which you basically make some overlapping. Then you can enhance the data itself, enhance the granularity of the data, and this it's basically you have to clean the data a little bit more. You remove irrelevant info, you verify the factual information that it's true, the accuracy. Then another important thing you can do is metadata, like how you actually organize the data itself. So you add specific tags, and I did a project of this, like a RAG for telemetry networking. And for example, the types of tags that I can use in this sense, it's I don't know, you have some sort of documentation, and you can say this documentation, it's talking about this specific protocol, right? And the thing is, like, these techniques that you can implement in pre-retrieval, they are not independent on self, but relying on the other types of optimization techniques you can implement. So everything goes together, and you can implement like most of them simultaneously. There's also this technique, small to big. So instead of using like bigger chunk sentences, you use smaller, and you use the rest of the query for as part of metadata. What else? We can do query optimization. So we can have the optimization within the data or within the query. And for the query, it's thinking, for example, about the logic. How do you route given different types of data? So given a question, I can ask myself whether I should search in a type of log or I should search in a different type of information database. That's it. And for query rewriting, it's basically take the query itself and paraphrasing the query. You can do synonym substitution, Or given the query, you can make subqueries. You can use another LLM to do this. Or you can use a hypothetical document embedding, which is a type of subquery. You ask an LLM to give you the answer of the query, and you input both the question and the answer, right? And then we can use query expansion also, or self-query, which is, it's a mapping. You take the query, you compute like the relevant structure info, like which keys, entities, which key events, and you make more structured search. You can do a search, a filter by metadata. Use this as a metadata to filter before making the embeddings similarity search. And within the retrieval, we can use hybrid search, which in essence is running the same query through multiple retrieval systems and then combining everything. We can do filter vector search, which is basically applying a previous filter using the metadata. And we can use post-retrieval optimization, two types. First, the prompt compression. So basically, we remove unnecessary information from after getting the relevant chunks, we remove unnecessary information, or we use re-ranking. We take top K most relevant chunks, for example. And in the book was also some info about the streaming versus batch. Like once you implement the system on itself, how are you gonna stream the data? So because what happens when the data itself changes? Are you gonna update it with like batches after some sort of like big changes, or like constantly through some period of time? And it has some advantages, disadvantages, but everything boils down to the specific use case. There's also this really important concept of CDC, change the data structure, of how are you gonna keep track of what happens when the data changes. The data of the database changes, and this data is the one used for answering for the RAG system. And it's very important to keep like this track using logs and also snapshots. So snapshots are like instances, fixed instances at certain time of your current state. And you have to have two types of snapshot. The first one is of the clean documents pre-embedding. So it's like a more raw version of it. And the second one is the chunk plus embedding. So it's like the final state of the data just to do the fast retrieval. So the second one can be replicated and recomputed if you have the first one, but you need the second one to do the embedding directly. And also at the end was a little bit about how do you make the actual integration with ZenML as an orchestrator, a little bit of OVM model, and finally, but everything, all of this was focused on the ingestion pipeline. In the next, probably tomorrow, I focus more on the fine-tuning itself, and that's it.
Okay.